this one, what is this? It's a computer. So this is a server that definitely if you are in the computer science and computer engineering, we are dealing with this machine. So this machine is very powerful. It has the CPU, memory, and the bus, interface, the processor, bunch of things. But without this, we cannot operate the machine. What is it? What is this? We need operating system. So we need operating system software you need to purchase. Sometimes there's open source software, so it's up to you. But this operating system depends on the hardware, your server, especially for what? CPU. Okay? So CPU is the most important thing. It's like so when I ask when my daughter was in the kindergarten, I asked her, she knows. She said that she knows what is the CPU at the time. So I asked her what is the CPU. CPU is like the brain in human being, right? It's correct. Okay? So it's a CPU, but depending on how to process the data, okay, it can be 16-bit or 32-bit, 64-bit. Also different, you need to have the different operating system. Okay, so once you have the operating system, you can. By the way, how does it work? How does it work? Operating system. So when you turn on your computer, what happens? There is a firmware, okay? The bus program. Then that program knows where is the starting point of the operating system. It's called the master boot record. Okay? So the firmware program should know where is the starting. Sometimes you can specify the order of boot, right? It can be started from the CD-ROM, then the USB, then hard disk drive, where is the boot record. Then boot record point has the point, okay, to specify the first program that is called what? Kernel program. Okay, that is the first program, that is the kernel program that will be loaded into the memory. First time, usually that process has process ID what? 0 or 1. Okay? From that, what is the process right away? Yes. Process. So I said there will be the first process when you turn on your computer. First process will be executed. What does that mean? Process. What? Job. That's a little bit the high level description. What is the process? Executed. Execution means what? Memory. Loaded into the memory. Process executable. What is the executable file? By the way, what is the executable file? You have a bunch of executable file in your cell phone, in your smartphone, in your laptop, computer. What is that executable file?
One program that can be executed.
What is the difference from the program that I purchased from the Best Buy? Executable file is the group of binary functions. It's the instruction code. It's a sequence of instruction code. How do you get such an instruction code? Compile. From high-level language, Java or the C++, whatever the language you use, you compile, then you can get the instruction, series of instruction that CPU needs that instruction. However, CPU cannot directly read the instruction from hard disk drive or USB, instead memory. Okay, because of the gap of speed. Okay, so even there's another cache area, it's an L4 cache. L2 cache, right? In your CPU. Okay, then that instruction will be loaded into memory, that is called process. It's a data structure. They feed the data structure for me. Okay? Then that is the first program. That first program, kernel program, will start another program. How can a process start another program? How? How can you start the process?
You give instructions.
Fork and Lec16. Okay? Actually, make the clone, copy of itself in the memory. Then load the instruction of other program. You don't have to load the entire instruction, instead, just as needed. Okay? How can do that? Just copy of the process. It's exactly same data structure. Depending on what? Depending on CPU. Okay? That's the reason your Windows XP4 AMD doesn't work sometimes with the Intel i5, something like that. Because each processor has different data structure, way of execution. So fork and Lec16 is separate. After you copy, make the clone and load the instruction and separate. That is new process. It's a children processes. Or process 1, process 2. It's a parent and children. It's a hierarchical structure. Eventually, there exists application program. We usually this end of tree process, we call them as the application program. There are many processes required to run your system, operating system. Okay, then DBMS is actually this level. So it's an application program to do something. So far we have learned about them. Okay, so we are ready. So we install the DBMS, Relational Database Management System, starter. Starter means it's the same thing, creating process of the database management system. And when the process is, a number of processes are started, okay? Each process has a job, okay? Some of the process will manage the buffer. Some of the DB process will be in charge of write. Some of them for the search. So there are a number of processes. Also, as I said, there is a reserved area. In where? Memory. So, when you are saying the starting of DBMS, database, that means creating process, number of processes. Also, reserved memory area. Oracle called this area as SGA, System Global Area. At least 50% of your physical hard memory, physical memory are required to be reserved. This size should be at least 4 gigabytes, something like that. It depends on the DBMS system. So after you start up the DBMS, there is also hard disk drive. So we have learned about how to design, how to manage the physical layer and the conceptual layer and external view, something like that. Okay, so we are ready to use the DBMS system. From now on, it's very important today. So far, I quickly overview the entire computer science subject. Okay, then we have another rectangle. What is that? It's also computer. Okay, this is a computer, this is also a computer. Depending on the role of computing environment, we are going to call this is a server. This one has the client. It's a client-server environment. There's no fixed rule. Which one is server? It can be client, also it can be server if this computer can serve for other services. Okay, but this time we are going to use this computer as the client. And this one has the program that is for database application, such as SQL Plus, that you have used in your exercise lab and in your project. So SQL Plus, using SQL Plus, what you can do? You can connect the database. By the way, what is the connection? When we are saying connect the database, what happens? It's a network issue, right? So this, most of the client server, under the client server environment, database connection, utilize TCP/IP protocol. From now on, it's exactly the same as the TCP/IP that you learn in your 471 or the 571, 472, whatever, network classes. So it requires what information do you need to establish the TCP/IP connection? So keep program, right? IP address, port number. Okay? In addition to that, database connection requires database information. There is a name. When you start up the database, there is a name. It's called instance name. Because sometimes you can create multiple instances under one database system. Okay? So this is called instance name. In Oracle especially, this is called SID. Okay? There is an instance name. So in the exercise lab is actually OICL. It's an instance name, it's a default name, Oracle. You can change the name when you create the database. Okay? Sometimes there is a number if you have the multiple instances. Okay? So IP address, port number, this is required for the TCP/IP connection to specify the specific database underneath the database name, and also username and password for what? Database authentication. Okay? Not operating system. Actually, that is the reason this database authentication is kind of security hole. Without information about the operating system, you can connect actually the server, right? So if, just in case, if you know the database username and password, actually without permission of operating system, you can connect the database. That's frequently happen for very small, medium-sized database. When you install the database as a default, there is a default name. So it's actually the testing user. Testing database user, testing database passwords like the Scott Tiger. Very, very popular. Or default name. For your testing sometimes, this for testing user, you can grant the administrator permission. Then at the time you can connect the database, then see all the information about it. Okay? So anyway, so using that information, that is the reason when you log on the database using SQL Plus, you need to specify username, your username, and password at ORCL. In ORCL, there is all information about this except the username and password. Also, for example, Java or the .NET, ASP.NET, any configuration, database configuration require this information as long as it uses the TCP/IP protocol. Okay? But ways the way of the configuration are various. It's different. So sometimes you need to define the object for connection ADO or whatever. It's different. So probably in your project, in your case 4, you need to figure it out how to set up to connect the database. It depends on which computing environment you use. That is the reason. I do not know sometimes if you are using different languages, which I never use, I cannot help you. But if you understand this basic mechanism, you can do that. So finally, we connect the database. So we are ready. We have the SQL prompt. Can you remember that SQL prompt? You can type. Okay. For example, I type select the column name from employee, table, department, and work zone. where employee DNO is equal to D number, and D number on the department is the control department, and the employee ID is 111, something like that. When you submit this query, what happened? What happened? Either return the data or error, right? That's correct. So today we are going to learn what's going on between your submission and return the data. There are a lot of things that happen in here. First, when you submit this one, this is the structured query language. Anyway, program language for database. Okay? Do you think the DBMS can understand this query language? No. This is just like the Java, just like the .NET, or any program language that you use. It's for human being, not computer. Computer definitely cannot understand such a high-level language. Only for human being. Right? How? Can make the computer understand your code? Compile. So you need to compile. If you are using Java, you need to compile the Java program with Java C. If you are using the Visual Studio, there's a compile. You need to specify the compiler to build your project, right? Depending on the program language. C compiler, C++, compiler, COBOL, compiler, something like that. What about this one? Is there any compiler?
No.
Is that there exists compiler, but it's different from other compiler. When you enter means submit. It is interpret. So it's called an interpreter. Interpreter is kind of compiler. It's the same as other compiler, but it works for line by line. So that is the reason this is end of the line. So it's a one line command, consider as a command. Okay, then submitted, it will be compiled by interpreter. So there are three steps in this. One is scanning. What does that mean, scanning? Have you ever learned the compiler? Have you ever think of, yes, what is the first step when you build a compiler? Compiler is a code, it's a program, it's an application program. You can code, you can make your own compiler. Then, what is the first step? What is the general step of the compiler? Yes, to convert your program language to the machine language, what do you need? First, you need to analyze the language itself, which means it's a lexical analysis. For example, when you code your program by the C program, your program should recognize name and left parenthesis, right parenthesis, and the deep bracket, INT, and AB. Okay? That is called lexical analysis. How can you do that? Very, very tedious job. It requires a lot of self-code. There's a specific name. There's a specific name of that. It's called the same function and index until you see the end of. And next, A, I, N. Once you identify the name as a keyword, then stop again, something like that. So this is called the lexical analysis. Similarly, here is called the scanning. Scanning means scan all this command, see whether this is one word. Okay? Select and next, comma, next, from. Some of them are keyword, reserved word. Some of them are none. Right? Doesn't matter. Okay? So scanning requires scan all your submission, then identify the word. The next one is parsing. After you scan this one, you need to check what? Syntax. Okay? You need to check the syntax. So whether select is correct from these two are required. And where is the optional, but in case of where, there should be the condition, whether condition is the define, something like that. Okay? Then that is called the parsing. Next, validate. Even though in terms of syntax this is correct, there is no EMP. Okay? Then that should be error. Right? In terms of syntax is correct, but there is no employee table. Then that's the error. That's called validate. Also, even though there exists the employee, if you do not have a permission, you can. So there should be error, and return to the something error message. So you probably see ORA dash something number. This is called error code. This is very important in database. So all your the debugging, all your the maintenance will be based on this error code. Okay? You can search from the Google. There is a tool even to search this one. So whatever you want, you can get. Most of the solution you can find as long as you get the error message and error code. So you will be error. If all of them are validated, this one will be saved as some intermediate code. Sometimes it's called a P code or something different name. Intermediate code that will be located into the memory, some reserved area. Okay, that is the first step. Scan, parsing, validating. Okay, then that is this is
Okay.
probably this one. No. One. What's the problem? Yes. The scanning, parsing, and validating. Okay, the intermediate form of query will be stored as somewhere in your memory. Why do we need to keep such an intermediate code in the memory? Why? Just for record? For reuse. Later, this same code, in case this code will be submitted again, we don't have to do again this step. Instead, just use this intermediate code. Is it really happen? Yes, it's a lot. Why? Most of the programming, as you realize during the page 4, it will be click. Nobody wants, no user wants to submit the SQL itself. Instead, they select the option and submit it. Okay? It will be same form, same SQL, by changing just the number. Okay? So during the scanning, parsing, validating, they don't care that this number. Okay? It will be used for the later. So the others are same. We don't have to do it again. Instead, we use from the memory. That saves a lot of resource. Okay? Then, next step is once this one is submitted, then saved in, there is a process to find best way. As I mentioned many times, it's exactly the same situation as the traveling from Bridgeport to New York. Okay? How many different ways? Huge different ways, right? So even we can take the I-95, the ferry, and the Long Island Expressway, or you can go to the New Haven and take the flight to the JFK and take the limo or helicopter. There are a bunch of different ways, but we'd like to find which way? Best. Okay? Fastest way, but that should be guaranteed. That's the most important one. Even though I-95 is the fastest way, okay, sometimes it can be stopped. It will never reach faster than the train, but who knows? If there is an accident or traffic, it will take 2 hours, 3 hours. So we'd better use guaranteed. The time is 1.5 hours to Grand Central Station. Okay, so that's the same thing in query process. Query process will determine the shortest, fastest way to access the data. Then you probably suspicious. How many different ways? Maybe 1 or 2. Let's see the reason. In this case, how first for each table. So for example, we have employee table. How many different ways of accessing only one table? First, linear search. Right? Linear search is from top to bottom. Access one by record. Actually, not record. It will be block by block. Because block is the smallest unit to access the data. So anyway, so we can access all entire block that belongs to people. What else? If this table is sorted by primary key, we can use binary search. What else? If this table consists of hash table, if this one is hash, we can use hash. Okay? And also, what else? If there exists clustering index, we can use the clustering index. First, this is the index, employee on the what index, and access the data. Okay? That's another way, clustering. What else? Secondary index. Usually B3 or B plus 3 index. Secondary. You don't have to write down this one. Okay? I don't believe my memory. We will see detail. Just ideas, see the ideas. So, secondary index. How many secondary index? Sometimes many secondary indexes. Let's say secondary index 1, secondary index 2. Let's say we have total 6 different ways in this case to access only employee tables. How many tables do we have in this case? Department has 6 different ways. Also work zone. How many different ways? 6 different ways. Total how many? 6 times 6 times 6. 216 different ways. Is that all? What else? You can access employee first, then department, then work zone. Or you can access department first, then employee, then work zone. How many different ways? Three factorial. Can you remember the probability? No? What is factorial? All line up n number. If you line up n number, it's an n factorial. If you consider the order n factorial, if you do not consider permutation and combination, do you remember that? Okay? In this case, factorial. So how many different ways? 6 more times. 3 times 2 times 1. So that will be already more than 1,000 different cases, different ways of accessing the data. We need to find one best path, best way to access the data. That is the job of query processing. Query processor will determine the best path. Okay? Considering what? That's the problem. So there are 2 different ways that query process to find the best path. Okay? One is rule-based optimizer. Second is cost-based optimizer. First, rule-based optimizer. So think about the travel to Manhattan. Airplane is the best one, bestest way. Okay, that's my rule. Okay, I don't consider traffic condition. I don't consider weather condition. I don't consider time. My preference is airplane. Next, drive. Third, train, always. So this is my rule. So whenever I travel, I apply my rule. So if there is the flight from Bridgeport to New York, I will select that one, no matter what happens. But unfortunately, there is no travel, no flight. Okay, in the circle city, the airport, it's a nearby airport. So next preference is drive highway. So that is my choice. It's the same thing in rule-based approach. In rule-based approach, there are number of rules based on priority. First rule is primary key access. If there is the primary key, okay, index, we will use that no matter what happens. The next one is the secondary index, and so on. There's a rule, usually 15 rules. There you don't have to remember, but that's the usually first choice is primary key. Last one is linear search. Okay. If there is a primary key, select this. We cannot guarantee this is really fastest one. However, the benefit of the rule-based is what? Simple. Because we don't have to worry about any condition, just apply the rule, then select the path. Okay? We don't consider cost, we don't consider any other condition. Just apply the rule. Problem? So this is not always the best choice. Think about the airplane. So let's say we have the airplane from the Circle City or the New Haven to Manhattan. Even very, very expensive. Also, it takes some time from Manhattan to the JFK to New York. Okay? We cannot guarantee always. Usually airplane is faster, but depending on the situation. Right? So it's the same thing. The rule base is working, just simple and works sometimes in small, especially small size database or the read-only, but we cannot guarantee the performance always. Accuracy is system performance is big way, long way. So next, cost-based optimizer. So let's think about the traveling to Manhattan. We need to think about cost. We need to think about the traffic condition, the departure time. Okay? So history, right? The weather condition. By considering this one, the most important cost is the time. Okay? So similar, then we will select the best way by considering our criteria. So I'm going to decide, even though on average usually the train is not better than the highway, not better than flight, so using the train is the best path. Okay? Similarly, query optimizer will consider cost of 1,296 cases first case, second case, up to the 1096 case. What is the cost? What is the cost? And we will query optimizer will select which one? High cost or low cost? Definitely low cost. Then, how can we define the cost of the query? What is the most expensive operation in computer system? Which one will take a longer time than other operation in operating system? Memory, CPU, read the data from register, or burst speed? Which one? I/O. Secondary storage I/O. Read the hard disk storage. Okay, that is the most expensive one. It's obvious in database system also. Database system deal with data stored in the hard disk drive, secondary storage. So we are not going to consider memory. We are not going to consider CPU. We are not going to burst speed or the latency. No, seek latency or whatever. Only number of IOs to access the data. Okay? It's not my rule. It's not the Professor Lee's rule. It's the general used in any development system. So this number of IO. So in other words, the cost can be calculated by number of counting IOs. For example, number one, this one suggests the linear search. Use the for employee, department, and workshop. It requires 100 IO. Number two, binary search, employee, department, workshop, it requires 200, and so on, 1,000 times 1,000. So this one is the best one, lowest cost. Let's select this. That's it. Can you find any problem? Yes. What can be the problem of the code space? It's called the CDO. Alright, this is called RBO. Rule-based optimizer. Cost-based optimizer. So cost-based optimizer looks like better than the rule-based optimizer, but still there is a problem. What can be the problem? What is the problem of the CDO? Cost-based optimizer. Take a while. Yes, good answer. For what? To calculate each and every cost. Okay? So 1,296 is a quite small number when you join 5 tables. Sometimes you can join the 10 tables, or sometimes you have many sequels in one. Right? Select from where, select from where, select from where. So it takes much longer time. Even, for example, think about when you travel from here to Manhattan, it usually takes less than 2 hours. But sometimes you spend 1 day to decide the location. Search, keep searching Expedia.com, and you spend 1 day. Doesn't make sense. Right? If you spend 1 day to decide the route, okay? From here to Manhattan. So, same thing, same problem. It takes much longer time. Also, even, how can we? This is after execution or before execution? Definitely, before you travel, you need to decide. How can we guess? This is just nothing but guess. Not real. So, for example, I'd like to travel to Manhattan. So, I need time, how long it takes. So you can ask to your friend, why don't you travel by train? Why don't you travel by airplane? Why don't you travel drive? Then let me know the shortest time. Then I'm going to say, doesn't make sense, right? Before that, you need to guess, anticipate, estimate the cost. You need to guess the number of IO before you travel, before you execute. How can you guess? That's another problem. So, to resolve the first problem, which means reduce the computation time, we can apply heuristic rule. Heuristic rule means, so we are not going to apply all these cases. Think about the traveling to Manhattan. Obviously, airplane is not so good choice, right? Nobody will select the airplane, right? It's expensive. It will take a time from JFK to Manhattan, right? So it rule out. So obvious case will be ruled out automatically. Okay? So same thing. In this, among 1,296 is a mathematical ideal case. Many of them, for example, so when you access the data, sometimes accessing employee is you have 1 million of employee. Department, 10 department works on the 10K. So if you have the specific employee ID, you will get only one, right? So you can get the one employee using primary key, then access this one. You can reduce the case. Otherwise, if you access the department first, for each department to check employee ID. How many times? 1 million times, something like that. So you can rule out obvious case. So we will see such a heuristic rule later. Idea is simple. Idea is, if you can rule out many the data, you can apply that first. Okay? To reduce what? Memory. So we will see the example. So the more data will be ruled out, the earlier you can apply such the operation. We will see such a case. The second, what was the second problem? The estimation. Yes. So we need to know how many data. Okay? In employee table, how many data in department, how many data workshop. Also, what is the distribution? For example, in case the gender is a half and half, right? If you build an index for gender, it's not good choice. Half of a million men, half of the million is a woman. Even though you build the index, there's no benefit. Okay? Something like that. You can get all the statistical information from each table, each column, each index. You need to collect. Without such a statistical information, you cannot perform cost-based optimization because it is based on estimation. For better estimation, you need to have better, recent, latest statistical information. Okay? So, sometimes when you launch the new database system, it works very well. Okay? So you got the very good response time. What is the response time? No idea? Yes. It's an operating system question in final exam, right? No? It's the duration between what?
From the standpoint to the processing point.
First response. Okay? Doesn't have to be full. So, why do I ask response time? Sometimes I forget the point. Where was it? Something statistical information. Oh yeah. So when you launch the new system, your response time is very short. It's a very good system, but a year later, so you apply the CBO, cost-based optimizer, so it works very well, but a year later, your query is very, very slow. Why? Because your estimation, your query optimizer will use last statistical data. If you never update such a statistical information, your system is larger, okay? Much 10 times larger than the first time, but your query optimizer will use old statistical data. So it will loud if you want to do it. Okay? So think about the traveling Manhattan. You have the year before information. At that time, there's no traffic in the I-95, there's no problem. But recently, there's the construction. So if we are using the old information, you may choose the I-95. Same problem. So to get the better performance, you need to keep updating the statistical data. So that is the job of query optimizer. We will see details. Definitely, rule-based optimizer is not very difficult. It's just a rule. Problem is a cost-based optimizer. How to compute such a cost? There's a function. Okay, cost range. Simple idea is a linear search. How long it takes? Number of a block divided by 2, right? On average, so complexity, right? So we will use such an idea. Okay. Then, before we start this one, the last question is, by the way, which one is better? Rule-based optimizer, cost-based optimizer? And so, rule-based optimizer is better. I'm asking. I will ask again the why. You understand? Finally, you can use my question. So it depends on the situation. Usually, cost-based optimizer is a better choice. That is the reason recently many of the DBMS system vendors, they set the default optimizer option as the cost-based optimizer. However, to keep the best performance, you need to keep updating statistical information. Okay? But still, rule-based optimizer is not the worst choice. In case what? When you have a small size database. Also, when you have the database, which usually read-only, not frequently updated, not frequently changed. Which means your system may be fixed, never changed. So your query optimizer will be never changed. So statistical information doesn't need. Okay, you know where it goes. So if you need it, you can create a primary key because that is the first choice. Okay? So it depends on the situation, but nowadays, so cost-based optimizer is kind of the core part of the relational database. So that is the reason Oracle has very nice cost-based optimizer engine and the method and the tool. So you will see during the exercise lab how the Oracle query optimizer is working. So that is the reason the Oracle is one of the best relational DBMS management system in OLTP. OLTP is an opposite of the batch job or data warehousing. It requires fast response time. Okay, at the time, because of this, Oracle is one of the best. So that is a query optimizer. Finally, output of query optimizer is the plan itinerary to visit the Manhattan. So you can use the I-95 and drive to the whatever, cross the something bridge and Manhattan. So you will show. However, we cannot guarantee whether this is the really best one, but it's the try to best using the cost-based optimizer to return the data. Even this query execution plan is saved in the memory and can be reused later. Then after, by using such a execution plan and get the data and return, the return data will be displayed here. That is the overview of the execution SQL language. So the later of today's class, and next class, and one more if needed. So we will see how this one is working. Okay? Any questions so far? So first, when you submit the query, query of the database engine will decompose your query by query block. Query block means one block has one select, one from, one where condition. This is one query block. Is there any multi-query block? Yes. For example, this one. So select last name, first name, whose salary is bigger than the maximum salary of department number 5. Okay? There are two query blocks. One is the select from where, here. Another one is select from where, here. Query optimizer can handle the two blocks, multi-block at the same time. Instead, separate that and process the separately. Okay? So in this case, select last name, first name from employee and where salary is bigger than something. And the next employee DNO 5. Okay? Obviously, in this case, this block will be executed first. And using that constant value, this another block will be used. At that time, if you know the relation